P sin phi, or Vp minus V dash P is equal to Ip Rp cos phi plus Ip Xp sin phi per unit regulations is given by. This all equations we are getting from phasor diagram. Per unit regulations is given by E is equal to Vp minus V dash P upon Vp is equal to Ip Rp cos phi plus Ip Xp sin phi Vp. I think you should get now. You can see IP means you can see it is nothing but current in primary winding, and IS means current in secondary winding. Thus, E is equal to ER cos phi plus EX sin phi. Thus, knowing the value of per unit resistance and per unit reactance, voltage regulations can be found for any power factor. Now, calculation of mechanical forces developed under short circuit conditions. So first you should know the mechanical forces. Interaction of current in the winding with the leakage field surrounding the winding causes mechanical forces on the winding. There are three types of mechanical forces. First is radial forces, second is axial forces, third is unbalanced axial forces due to magnetic asymmetry. It shows the leakage field in the core type of transformer. It is worth noting that windings carry current in the opposite direction. The leakage field can be resolved into its axial and radial components. It can be seen that forces are in two different directions. So here is the diagram for leakage field. Axial leakage field and radial leakage field. Radial forces. So you can see the diagram. The axial component of leakage field interacts with the current carrying winding and produces a radial forces Fr as shown in figure. Axial leakage field In this, you can find out the directions, current carrying winding, and produce radial forces whose direct whose direction can be found out from Fleming's left hand rule. The radial forces try to burst the outer winding and tries to crush the inner winding. That is, tries to burst outer winding, it is tensile force, and second is try to crush the inner winding is compressive force. So here is axial forces. The axial forces of leakage, the radial component of leakage field interacts with the current carrying winding and produces axial forces Fa as shown in this figure. It also, in this also the direction is found out by the Fleming's left hand rule. So what is Fleming's left hand rule? The magnitude of force which acts on the conductor is proportional to the product of current E and the intensity of magnetic field due to currents in neighboring conductor. The intensity of magnetic field depends upon current. So the forces on the conductor are proportional to the square of the current with normal load currents. These mechanical forces are low and can be neglected. However, in case of short circuit at full voltage, the short circuit current may reach to 10 to 25 times full load value, which raises to 100 to 625 times forces under normal condition. So the winding needs to be solidly braced or mechanically reinforced to avoid the damages. So here is types of mechanical forces. Mechanical forces are classified as radial forces, axial forces, unbalanced axial forces due to a magnetic symmetry. So here is a diagram for radial forces. You can see the diagram. So if you've gone through the diagrams, you can see, consider a core type transformer with cylindrical winding. Let the winding has T turns and carrying an instantaneous current I. So the instantaneous MMF acting across the duct is IT. So the flux density in the duct is given by VA is equal to mu 0 IT upon LC. So H is nothing but MMF acting along duct height. The flux density in the windings varies from 0 to BA.